We're going to look at trigonometry. This unit of trigonometry really is based on right triangle ratios. So the first thing that we need to make sure we understand is two kind of different ways to describe the shape of a right triangle. It can be described with either one, an angle. So for example, I can say we have a 40-degree right triangle. Or I can describe the right triangle as a ratio. And I can say, for example, the one side compared to the other side is in a ratio of 1 to 2. Okay, and we can draw a little slope triangle when we describe that triangle. And we can recognize the shape of that triangle based on that ratio, just as we might describe the shape of a triangle with an angle. But they're two different things. They're very different things. It's describing something with an angle, which is a measurement of this angle, versus describing that same shape with a ratio or measuring the lengths of sides. So we have in the past used ratios, and we're just going to start with the ratios. But what we're going to do a little bit differently now is we're going to just make sure we consistently label the sides the same. Okay, so when we talk about certain sides of a right triangle, we're always going to be talking about the same side so that there's no confusion on that. So this is what trig is all about then, is that we're just going to make sure that we label the sides in a specific way. And what we're going to do is label the sides as adjacent to some angle. For example, here, if we talk about angle A, the angle adjacent or next to angle A is going to be this side here. If I talk about another angle, if I make it relative to angle B, the adjacent side will be this side. So these are the same two triangles, but this angle B has a different adjacent side than the angle A, which has this adjacent side. So we have the adjacent side of that angle. We have the opposite side to the angle. So if I, again, look at relative to angle A, this side over here is the opposite side. Okay, whereas in this case, that same side was the adjacent side to B. And if we talk about angle B, and we talk about the opposite side to angle B, again, we're talking about this side here. So when we talk about opposite of angle B, we're talking about this side specifically, which is, we could also name, in fact, and just to be clear, we can name that two different ways. We can also call that same side adjacent to angle A. So it all depends. We have to make sure that we describe which angle we're making reference to. And then the third side is the hypotenuse, which is easy because the hypotenuse will always end up being the longest side regardless of the angle that we're talking about. So when we talk about hypotenuse of angle A, it's this one, and hypotenuse of angle B is the same side. So that's important that we are able to name these sides. Okay. So what we're going to do is we're just going to stick with describing these shapes with ratios. Okay, so we're just going to use the side length, and we're not going to worry about the angles for now. And we're going to describe these ratio shapes as fractions and decimals. And then we're going to use these same ratios to solve for these unknown sides of the triangle. So we're not going to worry too much about the names for this example. We'll kind of start talking about the names a little bit more formally. But if we were to talk about the side 6 here, it would be opposite of angle A, or we could also describe it as adjacent to angle B. And the side 8 here would be adjacent to angle A, and it would be opposite to angle B, and then the 10 is a hypotenuse for both angles. So I want to find the unknown. I've been given a right triangle here. All the sides have been solved for. I just want to figure out what these other sides of these other two triangles look like. So I'm going to maybe label this side, we'll call that side X. We'll call that side Y. And if I take a look at these two triangles, I can see that side 4 here is adjacent to side A. Side 8 is adjacent to side A. Or we could say opposite to side B, opposite side B. So these two sides actually relate to each other. So I'm going to write a proportion. And this is what we call a scale proportion, because it's going to be the scale factor which goes between these two numbers. So I'm going to do small to large, and I know that there is a small to large comparison for the other sides. So then I need to look for these other sides. So if I look at this side here, side 6, it's opposite angle A. Opposite angle A is going to be this side here, X. So I'm going to compare those two sides, and I did small to large here. So I'm going to do the same comparison in the same direction. These are ratios and proportions. So proportions have direction. So I'm going to do it as small to large. Okay, so that's the ratio that I have here, and this is, you can see the scale factor is when I divide those two numbers, I get 1/2, and then the scale factor must be 1/2. So I times by 1/2 here. That means I divide by 1/2 going this way, or I can, oops, sorry, I did the wrong way around. That's going to be times by 2. So I'm going to divide by 2 going in the opposite direction. Okay, so x looks like it's going to be equal to 3. Okay, we may choose to cross multiply this. Okay, again, this makes, as long as we understand the proportionality of the multiplying factor involved here, we can solve this by doing 4 times 6 divided by 8 equals x, and we get 24 divided by 8 is equal to 3, which we solved before. Okay, so we can see that our scale factor of 2 shows up between the two triangles in this multiplier going up and down. So I'm going to solve for side y, and I'm going to solve for side y by setting up a ratio, and this time I'm going to set up my ratio slightly differently. I'm going to use the opposite of side A, and I'm going to divide that by the hypotenuse of the same triangle. And this is, instead of writing a ratio between the triangles, I could also write a ratio within the triangle between the two sides. That's what I'm going to do the same, as long as I do the same for the other triangle. So in this case, I'm going to have side 3 compared to, because that's my opposite angle A, okay, opposite angle A compared to hypotenuse. So I need to compare that to the hypotenuse, which is going to be y. Okay, so I end up with 6 to 10 is equal to 3 to y. And we know that this, by scale factor, we know that's, I'm going to divide by 2 going from here to here, here to here, so that should be divided by 2 going from here to here. Okay, so that would have been using this ratio, okay, and this multiplying dividing factor. But I'm doing it slightly differently, and I'm going to find my multiplying factor this way. I'm going to say that from here to here is going to be times by 0.6. So then I'm going to divide by 0.6 to solve for y. So y is equal to 3 divided by 0.6 works out to be 5. Okay, and if we use our scale factor, yeah, this triangle is half the size of this one here. That side hypotenuse should be half the length, which is 5. Okay, and again, if you want, you could also solve this by cross multiplying. I get 6y equals 3 times 10. Okay, so y is going to be 30 divided by 6. And again, we get the same value that way. So we can, just a couple things to make sure we're clear on. This is just using a proportion. Again, we need to make, as long as we make sure the directionality of the proportion is correct, we can make the proportional comparison. And then we can use our times divide factors to solve. Okay, since it's times and divide, we can cross multiply. Okay, to solve this one. If it's not times and divide, okay, if we don't have a proportional relationship, we have some pluses in there, we can't cross multiply. Okay, in this case here, same thing, except now the difference is here I did a ratio comparing two sides, this side to this side, whereas in this example I compared the same two different sides in the same triangle. Okay, and we know that with proportionality, we know that there's a times factor going left and right and up and down. Here's our scale factor of times 2 going from the left to right. Sorry, from right to left, there's a times 2, just like we saw here, okay? Because we can turn these proportions around and we can still get the same times divide relationship or proportional relationship. Okay, so that's a lot of stuff, but basically we're using a proportion and doing a proportional comparison. So here we're going to do the same thing. So I'm going to solve for these other sides, and I'm going to call these maybe we'll call these unknown sides, let's call this one C and B. Okay, so we have side B and side C, and I'm going to do the same thing here as I did. I'm going to do a comparison, and I'm going to do this within the triangle. So I'm going to do the adjacent side to side A divided by the opposite side to side A. Okay, so I'm going to compare those two sides, and in this triangle here, I just got to make sure I keep it in the right direction. So I have adjacent to side A, well, that's going to be B. Okay, and maybe I'll just color code that just so that we're clear. That side goes with, that side B is next to angle A, which must mean it goes without. And so I'm going to do B, and then I need to do the opposite to angle A. Okay, opposite to angle A, yeah, opposite to angle A, opposite to angle A. And so in this triangle, I need to make the comparison of the side length of 8. Okay, so I did this to this is equal to this to this. Okay, and I'm using the colors. It should be fairly clear that we did it correctly. And then again, without the colors, we do need to double check these things to make sure we have it in the right direction. So again, I'm just going to, in this case, I'm just going to do my cross multiplying and solving this. So I'm going to do 8 times 8 divided by 6. Okay, maybe I should put it in brackets like this. 8 times 8 divided by 6 equals my side B. So B is equal to 64 divided by 6, which is 10 2/3. I'm just going to leave this as 32 over 3, okay, and which is approximately 10.67. Okay, we should start getting used to using fractions. I know we like to use decimals to know about how long. Okay, that 10.67 is an appropriate length for that side with this side B here. Okay, but again, the fractions are always going to be better. And then lastly, we'll do side C. So I'm going to use this triangle here. I don't have to use that other triangle. I can use this triangle that I solved for here. So I'm going to do C compared to 8. Okay, hypotenuse to adjacent to side B, hypotenuse to adjacent to side B. So it's going to be 5, 2, 3. Again, notice I am talking about the sides relative to the angles, and that's how we're going to keep track of these sides. Opposite side A, adjacent side B. We want to make sure we're using this language to keep track of these sides. And again, I'm going to cross multiply to solve this because I know it's a proportional relationship, and I know it's times and divide solves proportional relationships. So I end up with 40 over 3 is my answer. Okay, so this is approximately, again, the decimal value is going to be about 13.3 repeating. Okay, so I'll round that to 13.33.